What's the objective? What's the business objective of doing this?
Client registration.
They need to study, for example, to analyze how many students per course, per instructor. They need to study. Is there a pattern based on that? Maybe it's not less like enforcement education environment. Some other universities, it's optional to register any course. So they offer several courses, and then you can register. And then they see minimum requirement 5 students. That's okay. Go and open class for that course. So we need to study why majority of the students they are registering in this course. Is there a link between the knowledge of that course and the number of students they are registering, or maybe something else? Maybe the class is related to that course, maybe the lab, maybe the instructor. So this is I'm talking about business perspective. So we can utilize data warehouse to do so many analysis to just understand the business and do decisions based on. Now, what is the grand step in this text? Do you know? This is a business model. Now, what's the based on the business model, I can decide about the information I need. Yeah. So what are the information I need? It's like registration.
The course.
I need information about courses, instructors, students. Okay. Then move to the grade. Exactly what's the role you need to consider in the data warehouse. As I said, grade like bank account in month. Do you remember this is a grade? Registration, of course, in semester or in term. This is the grade. I have to define. In general, it's similar. And if you go back to the slides, grade is similar actually to dimensionality. But we are not talking about dimensionality in terms of dimensions like in the second step, step next. No, we are expressing those in terms of a statement. That statement related to the business. Like I will not say in a grade, oh, I need course student. No, don't list those dimensions. But speak about one statement that reflect one row of the table. So I will say students register in courses per semester. Actually, within these statements, I'm defining the primary dimensions, the dimensions I need. But next, now you have to specify and to add more dimensions. So the grade here is clear. The grade given would be one row for each registered course by student and term. I'm defining also the dimensions, but in general. Now, so what are the dimensions I need? It's clear. Course, student, term. Is there a way to add more? Yeah, maybe. If you need to support the idea, you can add more dimensions. But from the grade, those are course, student, term. What about instructor? It's not a part of the grade, yeah? It's not a part of the grade. But I said we can just support. So if I give information also about the instructor, I may come up with different analysis. I can analyze, I can explain the trend of registration based on the instructors. So I may have there is impact on that, and so on. So now let's go to dimensions. So we have defined the dimensions. What's the fourth? We need to define the measurements. So what are the measurements, and then we need to build the star scheme. What are the measurements?
It's like a data summary, could be algebraic, could be...
Yeah, but now for this case study, what should I consider?
Grade, like average?
No, see, then go back to the business model. Are you care about the performance of the students?
No.
I care about the registration. Then what's the measurements that could fit with this business? And this is, see, we are linking everything. It's not just a general idea, oh, I can use that. I know that you can use so many quantities, yeah? You can use grades, you can use number of courses, number of quizzes. But I care about the business model. The business model, they need to study just the trend of the registrations. Then the measurements should be how many? Count. How many? So how many students register in course A, course B? How many students register with specific group if I care about groups, specific level if I care about the levels, and so on. So the measurements counting how many students, count how many students register. Let's see. So for example, what are the other attributes within the dimension? Like start with course dimension and term dimension. What are the required fields?
The course ID.
It's not only just one field. Yeah, term. I can put just only one level. Term. Yes, term. It means the term 1, term 2, term 3, and so on. But actually, you have to add more descriptive attributes that give you more details about the term. Like, what? See what they are, what they need from the business.
Date.
In this table, the date for term.
Yes.
For term, then I need not the day. I don't care about the details of the day, how many students register per day. I care per semester. Yes, per semester. So the data is the term level rather than the more typical calendar day. Calendar day, it means that if you are speaking about the term, then you have to express that in academic way. It's in the calendar. Academic way, it means you know that we have a code 2172. So 2017 term 2. So academic way, or 2017 2018 semester 2, semester 1. So this is academic calendar. So spring, fall, another way to express the term. Academic year, and like this one, and so on. So let's see, for example, possible attributes that can be used with the term and with course. So I have, this is the fact table, course registration count. So how many students? If I'm talking about per student, then every student will have one record per course, only one time. Then let's think about term. Key that differentiates those terms. For sure, we need term key as primary key. You know the database. And we need a term. This is the actual key I need. Also, I can speak about academic year term and academic year. So what should I do? What should I see here in this table? Semester 2 with the code. This one. Academic year term 2017-2018. Academic year with term 2017-2018 T1 or T2. So, and here I can describe all the required information for term. Then for course, because I need the course. It's about of business and about of calendar. So what are the required information to define the course? What do you think?
Course number.
Course code, course name. What else? If you care about the description, then you can. No, I'm talking about the course.
By the instructor name.
Maybe category, yeah, under which, maybe department, maybe CS or CIS. So all of this information can be just used to credit, how many credit hours. So just select those information that will help you to analyze the trend later on. So maybe there is a difference. Maybe most of the students register this course because it has 3 credit hours. Then add credit hours as information. So you have to consider this one, and so let's see what they have. Course department, course format, course credit hours, course name, list of things. If this is a question in exam, I know that some of these will be different from a student to another student. Yes. But at least the minimum requirements should be satisfied. From where you can get those, and actually in the exams, whatever, there should be an explanation about the required information. Then you can put attributes. Let's see, for example, for student should be also a part, yeah? Yes. Then student, maybe student ID, student, this is the key, yeah? For every table should have a key. But now student ID is the one we are working on. Student ID. Do we need something else? So it depends on the business process, yeah? At least I need this one. if you need to add more, I care about maybe the their major, gender, maybe. I care about, for example, the addresses. Are they in campus or outside campus? So if you care about those, then add those attributes to the list. For instructor, I need instructor the ID and name. If you care about the name, then it's a part of the table. But actually, if you care about the reports, no. See, sometimes why do we are adding some descriptive information for the reports? So, for example, I analyze that most of the students they register course because of the instructor. Then who was that instructor? I can go back to the table and get name and report the name.
And by his name.
By his name and this. So see, I'm adding things so that I can get more informative analysis. Instructor address attributes. Okay. Department, instructor type. Is it full time, part time? Instructor indicator, original hire date, when. So for example, maybe the new one has low chance to have more students, yeah, and so on. Instructor years of services, how many years they are serving as a faculty member or as a staff. So all of these things from where we can get from these paragraphs, actually from these paragraphs. See, for example, let's think this is the first scenario. So yeah, they are talking about the major geography. So they are talking about address. This is why they have added something related to the address. I don't know what is it. This one, address, and so on. So in general, just such as part-time or full-time. Is it part-time? Then we added something to express this one, which is type, part-time and full-time. Residence, declared major, class level status, for example. This is also for the students now. I'm speaking about also the students. So let's go to where is the students? Students just here have 2. So this means that you have to add more. So if there is a question asking about what are the remaining attributes that should be added to the student based on this. Address should be added, yes?
Yes.
Location, is it on campus or outside, yeah?
Yes.
Full time. Residence also. Address. Major.
Also level.
Class level 1 to 5, according to this one. Or it could be level in freshman and these technologies. Senior, junior, and so on. So you have to add here more attributes that reflect these things. Now let's see another question. Can you write an SQL query for counting the number of registration for, because I care about number of registrations, yeah? For a faculty member, what do you think? I need to know just from this data warehouse scheme, I need to know just how many students registered per instructor, yeah? Yeah.
Select count and we can group by,
Yeah, group by. So tell me, it's a group by what? So now you have this. You have these tables. You have these tables. So you need to select what? The question is counting the number of registered just for faculty member.
Select the number. Select the instructor who had that course and get the number of registered students in that course.
Counting the number of registration for a faculty member. So I don't care about course now, yes? In this statement, I don't care about course in general. But if you need I need to say, for example, Dr. Fahad, how many students registered Dr. Fahad, regardless of the course. I'm teaching 3 courses, then the query will give me just how many students registered the total.
But is there a direct relation between the structure and number of students registered without the course?
See?
The question.
What, yeah. Is it possible to do that? Why I'm doing dimensions? I'm doing dimensions to get statistics, whatever. One dimension, two. Do you remember the cube? Empty, nothing. I can get statistics, how many students. Do you remember that cube empty? The apex one? Apex one, I said there is no dimensions. That cube will answer what from this table?
Faculty name.
No. The measurements I'm looking for in this database is how many students registered. Yes? How many students? Then if I'm saying there is no dimensions, then the answer is Muhammad. What will be the answer? There is no dimensions. I'm not talking about
A number of students. Yes,
Yeah.
yes.
In all. Yes.
The number of students.
Good thoughts.
Because you care about one dimension.
Yeah, I don't care there is no any dimension.
Yes.
It's like select sum of all. Just select sum of students, and there is no condition, there is no where, there is no group. What would be the answer? Sum of all the records.
Maybe 100 to 100 students.
Yes, that's a sum. Then it will give me the sum all. Now, if I can move to one dimension, like this question, it's one dimension. I'm asking about just only one faculty member. So I care about here. There is a link between this and the fact table. So I'll ask about just group by instructor name. Instructor name. Group by instructor name. So then the answer of this one will be what? Dr. A, this is the number. Dr. B, this is the number. If you care about just only one of those faculty members, then you will group by faculty members, and the condition where will be for specific faculty member. For specific faculty. So let's see possible answers. In the report, I care about instructor name, yeah? I need to see the instructor name. Count how many students. From where I get from the fact table and instructor as a dimension, yeah? Where group by instructor name. So I will see the answer is Dr. A have this amount, Dr. B, but I care if you care about just only one, add. If the question is about give a report number of registered students per instructor, then in this case I'm not asking about a faculty member, an instructor. I'm asking about all. So you have to remove this one. In this case I'm asking about specific instructor, then just compare instructor character from instructor key equal the course registration. Instructor key. Course registration is the fact table. Course, which is the fact table. So these are the right information. So can you write an SQL query? Good. Can you write now? This is just general question about SQL query for counting, regardless of the cube or whatever. Now, this question is asking, can you write an SQL query for construct data cube? Data cube. Cube by, yeah?
Yes.
Do you remember the lattices? Yes. Do you remember that the lattices that when you have lattices means all of these cubes that I said that all. Which is apex, and then here I have one dimension, and then we have, I can link this with this, yeah?
Yeah.
This with this, this with this. This is second level. Then I can just link, come up with the third level, yes? All of these together. Now, every point here is a cube. And I said the number of cubes.
Number of 2 to the power.
That's 2 to the power. How many dimensions I have here? 3. And to the power 3 equal 8. This is if I'm considering. Remember, if I'm considering what? That every cube, every dimension has just only one. Every dimension. So I care 2 because just every dimension has just only one level. Like what? What's the level? Now let's speak in details. What's the level for dimension? Let's think about dimension in the course. The student, not the student. The instructor. It's the course. Yes, course dimension. How many levels they have? Name, maybe department, maybe format, maybe course credit hours. So I have 1, 2, 3, 4. In this case, how many data cubes I may have? Let's say this is course. 60. And this is 10. Now I'm talking about this point, just only. In the normal, if I have just only one level, then the theory, if you remember, that was product of 1, I equal 1 to n dimensions, then level in each cube, li plus 1, yeah? And I said this one will be that I equal 1 n if the level is just only 1. For every dimension I have just only one key, like the name of the instructor, the name of the course, one level. In this case I will have 1 plus 1, which is I equal 1 and 2, yes? 2 times 2 times 2, it will give me, for example, like this one, 2 to the power 3. So now if the question is asking how many cubes can be generated based on this scheme? Is it 2 to the power 4? I have 4 dimensions here, see that? Yes? So is it 2 to the power 4? Is it 2 to the power 4?
No.
I have to apply this one. This one, the course, is not just only one cube. If I have one level, it will be one cube. But if I have 2 level, it will be just the level for this one, level for the course. How many instead? 4. And then for the term, how many? We see for the term 1, 2, 3, not the key. Don't count the key. So you have 3. And so on. So actually I can calculate the whole thing here. It's like I equal 1, n in this case n4, yeah? In 4 dimensions. I need to say level I plus 1, which is actually for the first dimension I equal 1. Course. The course how many? We said you said 1, 2, 3, 4 plus 1, which means that I have 5 times. How many for the term? 3 plus 1, yeah? 4. And then the third one, please help in the student. According to this, it is 2. 1 plus 1, yeah? Which is 2. But we may have more. But if this is just given us like this, then I have 2 times the last one, which is 8. So this is the number of possible cubes you can have. It's not 2 to the power 4, 16. Huh?
7 plus 1.
Yeah, 7 plus 1. So it means this is the whole number. It's not 2 to the power 4, which is 16. And why we have this number? Why it's not 2 to the power? Because every node can have several cubes. I can have 4 for the course. I have course based on a cube for course based on what is name. Maybe I have also course dimension but based on the department. And this is why in the below SQL we generated report based on instructor name. We can generate based on instructor time. So what will be the difference? If I'm asking you, can you give me a report, possible report, synthetic report for this? Since I said that I may have cube for this one, cube also for this one. What are the possible reports, output? Here.
For all these data.
No, I'm talking about the report, the style of the final report. If the query is about instructor name, then I will have instructor name, yeah, instructor name and count. How many registration, yeah?
Okay.
Count. So in this case, I will have A, B, C, doctor A, B, C, and then I have just numbers. Numbers here. I can have another view from the same dimension, but in this case, I'm talking about instructor type. And then I have count. But type, I may group A with B and instructor A, instructor B. They are under one type, which is, for example, let's say the type could be assistant professor, associate professor, and this. So A professor, AC professor or professor. Then I have here numbers. So can you get the idea? So I have different cubes for everyone, and this is why I'm counting there 5 and so on. Okay.
Why you compute like 4?
4 dimensions.
4 dimensions?
1, 2, 3, 4. Then I have four products, yeah? Types, okay? So let's go to we answered this one. So see, select academic here, course name, instructor type, from course registration, from the fact table, cube by, yeah? Because the question is to generate cube.